I'm going to do a little quick review before I teach you Descartes.
Oh, man, no. I hate this stuff.
Yeah, because there really wasn't a lot of guided notes on this.
He's stealing stuff. He's got a calculator.
He's got a pencil right there in front of him.
I know.
All right, possible rational zeros. Here we go. We've talked a lot. What's wrong? You're not ready yet? Okay. Tell me when you're ready, Stella. Okay. We talked a lot about factor and remainder theorems, how to tell if something's a factor when we divide, how to factor fully given a factor, all of that good stuff. So now we're going to talk about if we don't have like a springboard to go off of knowing what is a factor and what is not, how do we find them? And this again is just a review from Algebra 2 so I can get to new stuff for today. Yay, new stuff, right? Right. Okay. Possibles. Just what it says, it lists out things that may or may not be zeros. So if I have a polynomial, let's say 2x cubed plus 11x squared plus 28x plus 24, and I ask you to find all the zeros of the function. Real, non-real, complex, every kind of zero there is. Your first gut instinct would probably be to do what? Try to factor, slash it, right? In the case of this one, it doesn't work. I can't slash it because it doesn't factor from there. So then I have to back up and punt and go, okay, well, what else can I do? Any ideas? Okay. That's not right. I'll list out the possibilities, and here's what the possibilities are. They're the PRZs. I don't know if you guys remember this or not, so I'll ease into it. Okay, so this does not mean these are zeros. These are possible. I keep stressing that. Possible. They may or may not be. I do plus or minus factors of the constant divided by factors of the leading coefficient. Y'all remember it now?
Maybe when I see it, I will.
Okay. What are the factors of 24 in order? Go in order for me. 1, 2, 3, 4, 6. Those are factors, right? Factors of the constant. What about the leading coefficient? What are the factors of the leading coefficient? 1 and 2. So my goal to find all the possible zeros is to list out, and possible rational, these aren't going to include any imaginary, these aren't going to include anything like that, but rational meaning fractions, right? And it can be written as a fraction. So possible real zeros here. Every single combination of these numbers divided by these numbers. Every single combination of all of these numbers divided by all of these numbers. It is a lot. It's a lot. So what I'm going to do, I generally will take all of these numbers and I'll divide them first by 1. Then I'll take all of these numbers and I will divide them all by 2. Then take them all if there was another one and divide them again. You don't have to repeat here though. So if one shows up again. So let me show you what I'm talking about. So my PRZs here, which means my possible zeros, right? They may or may not be a zero. Plus or minus. If I divide all these numbers by 1, you get the exact same numbers. Yes. Now I take all of these numbers, I've divided them all by 1, now I need to divide them all by 2. 1/2. 2 divided by 2, that's 1, that's already on my list, I don't need to repeat it. 3 divided by 2. 4 divided by 2 is already on there, I don't need that. 6 divided by 2 is 3, that's already on there. 8 divided by 2 is 4, that's already on there. 12 divided by 2 is, that's already on there. 24 divided by 2, and that's already on there. So there are my possibilities. What good does that do me? Y'all don't remember? You're exactly right. You are exactly right. So two things we could do. You're using that factor theorem, that remainder theorem, which is awesome. You plug it in if you get 0. But instead of plugging it in, I think that I'll do synthetic division to see if I get no remainder. That way I could factor it all the way. Okay. So now I'm going to test until I find one that works. What? You remember now? What's wrong? Your hair tie? You know. We'll test until the remainder is 0. So pick one to start. It really doesn't matter. And this is where, do y'all remember me showing you the little shortcut so you don't test them all? It might. I don't know. Let's see. Yeah, it might start with -1.
So that has just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 20% possible.
Oh! It still doesn't work. But I did it wrong. Okay, so the shortcut that I showed you was I told you graph it on your calculator and see if you could kind of, because you'll show your work, but if you know a good starting point, it will really help you. So if I were to graph this function and look at it and see if I could tell someplace that maybe it crossed, let's see, 2x. Now, if you didn't have a calculator, which you may not, the only place on here I see where it may cross, it looks like -1.5. It looks like -1.5. Right, but make sure you show that 1 at least. There could. Yes, and all right, guys, and I'm just guessing. I'm looking at it, and I'm really just, before I make my way down this entire list, plus or minus 1, plus or minus 2, before I do that, I just kind of use my calculator to cheat a little bit and give me a point to try that I thought might would work. And it looks like it crosses at -1.5, so I'm going to try -3/2. And so I get 2, that would be -3, which is 8, which is -12, which works. That's the goal, is finding that factor, finding that 1 that gives me no remainder whenever I divide. So now what does this mean? Because I need to find all the zeros of the function, and that's just one of the zeros. Well, that means now I can say, okay, well, that means x plus 3/2 times 2x squared plus 8x plus 16 is the same thing as what I started with here. It's opposite sign on there. Because the 0 is negative 3 over 2, which means if you set that equal to 0 and solve it, you get the negative 3. So it's same sign of zeros, opposite sign of factors, if that makes sense. So now I can finish factoring and find the zeros. And maybe I can factor it, maybe I have to use quadratic formula, but I at least am down to a quadratic now, and I know I can find a quadratic. So I have x plus 3 halves. I'm going to pull a 2 out of here first. And I'm going to just throw it in the front. What multiplies to 8 but adds to 4? Oh, wait, what's wrong? Okay. Multiplies to 8, adds to 4? Oh dear, what does that mean? It's the quadratic triangle. No. And these are going to be imaginary solutions, so definitely not. All right, so there's one. I need to include that. Opposite b plus or minus the square root. B squared minus 4 times a times c all over. You remember your song? Y'all song was good. That's right. So I get negative 4 plus or minus 4i over 2, and I can divide everybody by 2, so I get negative 2 plus or minus. What? Why are you making the 4 negative? Four times 1 times 8 is 32, so 16 minus. Say that one more time. I'm sorry, my. It's not, so PRZs only find possible rationals, and they will not give you complex or imaginaries. Anything past that, right. PRZs are just a tool used to springboard you into all the other solutions. Because it doesn't say find all the factors given a factor or find all the zeros given a zero. It gives you nothing. And it could be, and I know y'all will remember this whenever I tell you, because y'all remember everything from Algebra 2. It could be that I PRZ it, and this is not a quadratic, but this is a cubic or a quartic, and I might have to PRZ this. So I could, in fact, on one of your tests last year, I don't know, well, of course you remember this, you had a double PRZ quadratic formula question. Do y'all remember that?
No,
Had to PRZ twice and then use quadratic formula. Ah. So remember, it's a cubic, so I should have 3 zeros. So I have this 0, which is negative 3 over 2, and then this gives me 2 complex zeros, negative 2 plus 2i and negative 2 minus 2i. It doesn't impact your solution, because if you think about this equaling to 0, I could really divide both sides by 2. It would just go away. And then I set that. Yeah, and 2 is never going to be 0, right? So it's really not going to impact my answer. All right, I had not planned on doing any more than that, but if you would like me to do another example, I'll be happy to. If y'all, yeah, let's do one more. I see no and yeah. Yeah, but it's not on this. It's on Descartes and this. Oh. I haven't learned this. This I was just reviewing you, but yes. This one. We haven't got to the lesson yet. I was like,
Just go ahead. Yeah, just go to the left. Go ahead. I'm sure if I don't understand.
are you sure? This is a pretty cool little rule. It just kind of is a little, it helps you with some, we're going to start easy with it. It just kind of helps you whenever you have lots of PRZs. It is French.
Wow.
Rene Descartes. That's probably saying it wrong. How would you say Descartes? No, how do you say? I'm sure it sounds a lot better though than the way I'm saying it. There you go.
It reminds me of the cartel.
This rule, I'm going to give you some background since y'all asked so nicely. You might need it for quiz bowl. You never know. They might say, who was the French philosopher? What? All right, discovered by the French philosopher in 1637. His name was Rene Descartes, and he discovered this to help eliminate possible zeros from a lengthy list. No, I was just letting you know. That's just who Descartes is. That's who Descartes is. All right, here's what happens. We use variations in signs of a polynomial you don't have to write this if you don't want to determine, because I'm trying to make it concise and I'm going through it in my head and I'm making it kind of long. We use the variations in signs of polynomials to determine the number of positive and negative zeros. Here's what we're looking for. What's consecutive mean? In a row, right? Consecutive alternating, what does alternating mean? Consecutive alternating signs. Okay? That is going to tell you the number, and here's where it gets a little confusing. The number of positive zeros or let's say even. For example, if signs alternated 8 times, there were 8 alternations of signs, and I'll show you what this looks like. That would mean I could have 8 or 6 or 4 or 2 or 0. You're not going to have this many alternations. Alternations, not alterations. Great day. All right. If it was 2, or let's say I had 1 alternating sign. That means I'd have 1 exactly, because I can't go down an even number, right? I can't go down below that. No. It's just for positive. For the negative, you do the same thing, but you do the alternating signs of f of negative x. When I show you, this is really easy, y'all. It's just wordy to try to write it. I just want you to have something in your notes that you can go back and look at to kind of spark your memory on what you do. Alternating, consecutive, alternating signs, and everything. Consecutive. So as my leading coefficient and my constant get bigger and bigger and bigger, that's when Descartes really helps you. But I'm going to start with an easy example. And right now, we'll just list the number of positives and negatives before we actually use it, okay? You ready? Yes, so it would go 5, 3, 1. Yep, yep. All right, let me give you an example. I can always tell when y'all are done writing because Brian starts talking. All right. I would say state the possible number of positive and negative zeros. Yes, for this, but let me show you how easy. Let me show you how easy. Not much. You got enough there. You got enough there. All right. How many alternating signs consecutively do you see? All right, look. 1, right? 2, 3. Any two beside each other that have opposite signs. So do you agree there's 3? There's 3 sets. 1, 2, 3. 3 times the sign changes right beside each other. So my possible positives, that's exactly right, Zoe. 3 or 1. Good job.
So why is it positive but the numbers are odd? Like I positive but even. No, you don't have a positive. It's not real number.
Why is it?
Because it goes down by a number. No, because when we wrote
Oh, down by an even number. Like so 3 minus 2, or 3 minus 4, or 3 minus 6. Is the down by an even number thing? Okay. I'm not talking about down. What's an even number? Give me an even number. Easiest one, 2. 3 minus 2 is 1. If I minus 2 again, I'm in negative, so it doesn't matter. If I start at 7, down by 2 would give me 5. Down by 2 would give me. Down by 2 would give me. Down by an even number. That's the possible positives. Nope, never down by an odd. That's exactly right. That's exactly right. All right. Negatives. Here's where it starts getting. Are you confused? I'm talking about how I came up with 3 or 1. All right, so the 3 is because there's 3 here, and then I subtract 2 to get 1. Yeah. Yeah. Okay. All right, let's do the negatives. To do the negatives, I have to find. Oh, great day. I have to find f of negative x. Okay, so everywhere. Now, here's what you have to remember. If you raise something to an odd power, it keeps its sign. If you raise it to an even power, it becomes positive. Okay. Odd powers keep the sign. Keep the sign you plug in. Even powers positive. And that might, I'm hesitant to even write that because that's, if you think, anyway, okay. All right, negative, f of negative x. So this is going to be 4, this x is going to be negative. And you don't have to plug it in this way, you'll be able to see it, but I want to show you step by step why. Oh no, I'm sorry. All right, I just plugged in a negative x for every x. Because it's to an odd power, it keeps this sign that I plugged in. So this would be negative 4x to the 5th. This becomes positive minus 3x to the 4th. That's why I said it really, if it's negative, okay. It was already minus though. It only makes this part positive, right? Now, this is going to be negative, so minus 7x cubed plus x squared. This is a negative and a negative, which would be plus 6x minus. Why? So I really, what I should say is odd powers change the sign. And even powers keep the sign. Instead of saying, I'm talking about, because what I was referring to is keeping or changing the sign of the negative x. But instead of doing that, let's just say it like that so it helps you. So odd powers change the sign. So this was an odd, odd, odd. They all changed. All the evens stayed the same. So now same thing. How many alterations or alternations do you see? Well, negative, negative, oh, here's 1, and then 2. So that means the number of negatives are just what? 2. Or 0. Second. Yes. Yes. All right, let's do another one start to finish. Because you're plugging it, this is only when you plug in negative x. So if you raise a negative number to an odd power, right, no matter what that odd power is, it's going to stay negative. So if I plug in a negative that wasn't there before, it's going to change the sign of whatever was there. It became positive. Remember, we're doing lots of things to try to help us with possibilities because we don't really know what the zeros are. So this is another way that helps us with possibilities. It tells me that I have either 3 or 1 positives, and I have either 2 or no negatives for my PRZs. So yes, you would divide synthetic from there. But before we get into all that, let me make sure you got Descartes. Huh? Because you do 2, you got 2 sign changes, and then you subtract 2 from that. Try this one. Tell me the possible numbers of positive and negative. We will in a bit. Maybe not right now.
So that's it?
That's Descartes. I'm fixing to pull it all together for you. I know. Don't look so sad. Yeah. I'm sorry, Madison. Yeah, you look so apprehensive. Is it what?
Wait, so what? You told us to do this by yourself?
Yeah, by yourself. You need me to do it with you?
No, I thought I didn't know what we were doing.
I know what I'm doing right now.
Yes.
Hold up. I got that.
I got three.
I got that.
I only got three.
I got that.
I missed one.
Does it really? Brian. No crumbs.
Let's get it.
You're ready for the test? So -2x4. I got +2x4.
What happens when you raise to an even power?
It turned even. Yeah.
It turn-
It turned even. It's okay. Oh.
When it's, yeah.
-2.
Right. All right, let's pull it together then. Oh yeah, sorry. So yes, we're going to use PRZs to find all the zeros, but we're going to use Descartes to eliminate some of those off of our list of PRZs. Let me show you what I mean. Yep. You can do either one first. It doesn't matter. That many positives or that many negatives. Okay, well, we've been doing kind of easy ones for these. I mean, think about if it, okay. Let me just show you. Okay. Let's list the PRZs first. Plus or minus 1, 2, 4, and 8. Again, this is an easy one because my leading coefficient is 1, right? Okay. if I use Descartes' rule of signs, then I know, based on this, I should have one possible positive. And then if I do, and the more you do these, the quicker you get an f of negative x, right? Because you're just looking at the power really on the x. So if I think about f of negative x, I'm going to have x to the fourth minus 6x cubed plus 7x squared plus 6x minus 8. 1, 2, 3. So negatives, I'm looking at 3 or 1. Okay, so why is that handy? Well, that's handy because let's say I started with 1 as my PRZ to test, right? And I test 1 and I go, okay, 1, 6, 7, negative 6, negative 8. Drop it, multiply, add, 4, 8, 8. It works. That's my only positive because I know I can't have more than one positive. So now I know if I need to try anything else, I only need to try negatives because there are no more positives. Or one of them, right. I've already used that up. So it's actually x minus 1 times. Correct, that's right. Plus 7x squared plus 14x plus 8. And maybe I try to slash it here, but whenever I look at it, I go, but wait, it doesn't slash. This is another PRZ problem, right? But now that I did Descartes, I know there's no sense in wasting my time doing any positives because there's only one positive, so my last ones must be negative. So I guess let me try negative 1 on this one instead of, you see what I'm saying? Yeah, you got a new polynomial here that you're trying to factor. What? Yeah, this is. So now I take this and I'm PRZing this.
So once you get that one.
Because my whole goal is to get it factored down completely. And I can't slash that and factor it the way it sits. But listen, I might not have to. I can factor that like normal now. What multiplies to 8 but adds to 6? 4 and 2. If I solve these, I get 1 positive and 3 negatives. Isn't Descartes pretty cool? You should see it. They were picking on me in college.